Come to the solutions for a final exam on Calculus 1. The first question in this test is as follows. That's the final, sorry. We're supposed to give the most general antiderivative of the function f of x equal to, open parentheses, x minus x to the power half, close parentheses, whole square, is equal to, and that's what we have to figure out. So integration of x minus x to the power half all to the power 2 equals to, we'll expand this, that will give us x squared minus 2x to the power 3 over 2 plus x. Now we can just do normal polynomial integration. So the first term will give us x cubed divided by 3 minus 2x to the power 2.5 divided by 5 plus x squared divided by 2 plus the constant of integration. So the answer will be x cubed divided by 3 minus twice x to the power 2.5 divided by 5 plus x squared divided by 2 plus constant. Question number 2. The function f of x equal to x squared divided by x plus 1 is increasing on the intervals, and we have to figure out the intervals. To do so, a function will be increasing when its first derivative is positive. So we will take the first derivative of the function, and since this is a rational function, we will use the rule which states that we have to have the denominator multiplied by the derivative of the numerator, and that will give us 2x multiplied by x plus 1 minus the numerator multiplied by the derivative of the denominator. So that's going to give us minus x squared, because derivative denominator is equal to 1, divided by the denominator square, which is x plus 1 all square. If we do the math, this is going to reduce to x squared plus 2x divided by x plus 1 all square. We conclude that x equal to 0 and x equal to negative 2 are critical points, because these are the zeros of the function. So these are the critical points. If we solve this equation by saying x squared plus 2x equal to 0, we will get x equal to 0 and x equal to negative 2, which are the critical points, or we can say the zeros of this function. We can also conclude that the denominator implies that the function has a vertical asymptote at x equal to negative 1. So now that we have identified the critical points and the asymptote, we can just look at them over here. So we have one segment of the function to the left of this critical point, which is at negative 2. So to the left, from infinity to negative 2, we have to examine the function, and then from negative 2 to negative 1, where the vertical tangent is, this is a different segment, and the third segment is from negative 1 to 0, and the last segment is from 0 to infinity. So we can write the domain of the function as follows: negative infinity to negative 2, that's the first segment to the left, union negative 2 to negative 1, which is the second segment, and then union from negative 1 to 0, that's the third segment, and then the last segment is 0 to infinity, which is this one. If we do the second derivative, that's the second derivative of the function, it will yield x plus 1 multiplied by twice x plus 2 minus 2 multiplied by x squared plus 2x divided by x plus 1 all to the power 3. F double prime of negative 2, if we do the math, we're going to get negative 2. Implies f has a maximum at x equal to negative 2. And f double prime of 0 is equal to 2 implies f has a minimum at x equal to 0. The function's derivative will be negative for the following intervals: negative infinity, comma, negative 2, union, negative 2, comma, negative 1, union, negative 1, comma, 0. On the other hand, the function's derivative will be positive only for the interval from 0 to infinity. So the answer is interval is from 0 to infinity. Next question is question number 3, and it's about the function f of x equal to 2x cubed minus 3x squared minus 12x. We have to find the sum of the absolute maximum and the absolute minimum values of the function f of x. So to do that, we have to start with finding the first derivative. So f prime of x will be equal to 6x squared minus 6x minus 12. Thus, if we take 6 as a factor, we will get x squared minus x minus 2. If we equate that to 0, it will imply that x equal to negative 1 and x equal to positive 2 are the critical points. If we take the second derivative of the function, we'll get 12x minus 6. Thus, evaluating the second derivative as at the first critical point, which is negative 1, will give us a negative value. So that means that we have a maximum there. And if we evaluate f double prime of at x equal to 2, if we evaluate f double prime at x equal to 2, we get a positive value, and that means we have a minimum at that point. So there is a maximum at x equal to negative 1, and there is a minimum at x equal to positive 2. Therefore, the absolute minimum, lowercase m, will be equal to, we have to evaluate it from the function equation. So f of 2 will be equal to 16 minus 12 minus 24, which will give us negative 20. We'll do the same for f of negative 1. That's going to give us negative 2 minus 3 plus 12, and that's equal to positive 7, and that is the maximum. So, however, the endpoints imply that f of 3 will be equal to 54 minus 27 minus 36, and that will give us 9. So we can conclude that there are two minima. One is negative 20 at x equal to 2, and the other is negative 9 at x equal to 3. Consequently, m equal to negative 20. Since there is only one maximum, capital M equal to 7, therefore our conclusion that lowercase m plus uppercase m, or absolute value of minimum plus absolute value of maximum, will be equal to negative 13, which is the answer. Next is question number 4. Next question is question number 4. For question number 4, we have to find the value of the local minimum. lowercase m of the function f of x equals to x minus square root of x. And to do that, first we have to get the first derivative. So the first derivative of the function is x. Derivative of x will give us 1. Derivative of square root of x will give us 1 divided by twice square root of x. Therefore, setting f prime of x equal to 0 implies that twice square root of x equal to 1, and that will lead us to 4x equal to 1, and that will lead us to x equal to 1 over 4. But we're looking for the value of the minima, lowercase m. So to find that, we have to evaluate the function f at 1 over 4, and that will give us negative 1 over 4, and that is the answer for this question. Let's move on to the next question. For the next question, we have some statements, and we want to see which of the statements is true about the graph f of x equals to x multiplied by e to the power negative x. And here are the 4 options from which we have to pick up the correct one, or the true one. To do so, since it's about concavity, then we have to go for the second derivative to decide the concavity. And to do so, we have to go the first derivative first. So the first derivative, f prime of x, since this is product rule, so we do the derivative with respect to e to the x, and that will give us negative x e to the negative x. And then we do the derivative with respect to x, and that will give us e to the negative x. And this will lead us to the second derivative, which is f double prime of x. F double prime of x, we'll do it the same way, so it will be x e to the negative x minus e to the negative x minus e to the negative x. We can factor out e to the negative x. We will be having e to the negative x multiplied by x minus 2. This implies that f double prime of x is less than 0 only for x less than 2. Because when x less than 2, we're going to get negative value for f double prime. And this is the only way. Anything greater than 2 is going to give us positive value. But we're looking at the negative value here. So what does it mean to say the negative value? Whenever f double prime of x is negative, it implies that f concaves up only for the interval from negative infinity to 2. And for that, we can see that the question answer is going to be the last one, which is concaves up on the interval negative infinity to 2. And that's the correct answer. That's the true answer. Let's go to the next question. The next question, number 6. Limit as x goes to 0 of cosine x minus cosine 2x divided by 3x squared. To find the limit first, we have to plug in the values and see what we're going to have. So we're just going to replace every x by 0, and if we do so, we'll get cosine 0 minus cosine 0 divided by 0, which is 0 over 0. So that will qualify us to use L'Hopital rule, because the hypothesis is tested and we're ready to use L'Hopital rule. So we have to do the derivative of the function. So derivative of cosine x negative sine x, derivative of cosine 2x is negative 2 sine 2x, but since we have a negative, that will make it positive now. And derivative of 3x squared is 6x. Now we're going to go ahead and plug in 0 for every x also for this derivative, and it's going to give us sine 0 plus twice sine 0 divided by 0 also is 0 divided by 0. So we're going to have to go to another round, and we'll do the derivative also. Derivative of negative sine x is negative cosine x. Derivative of twice sine 2x is positive 4 cosine 2x. Derivative of 6x in the denominator equal to 6. we will plug in 0 for every x. That will give us negative cosine 0 plus 4 cosine 0 divided by 6, and that's going to give us negative cosine 0 is equal to negative 1. Positive 4 cosine 0 is equal to 4. And negative 1 plus 4, that's going to be 3. 3 divided by 6 is equal to half. That's the correct answer. Let's move on to the next question. The next question is as follows. Integration of sine to the power 6 of x multiplied by cosine to the power 3 of x dx. Now, for this integration, we're going to keep sine to the power 6x, and then we're going to split cosine 3 to the power 3 of x into 2, which is cosine to the power 2 of x multiplied by cosine x dx. We could go ahead and go further to check cosine square of x and replace it by its identity. So that's going to be integration of sine to the power 6 of x, and then open parentheses. Instead of cosine square of x, we'll write 1 minus sine square of x. And then this is multiplied by cosine x dx. So we can see that if we plug in sine to the power 6 inside, that's going to give us sine to the power 6 because we multiply by 1, and then minus sine to the power 8, which is over here, sine to the power 6 multiplied by sine to the power 2. That's going to give us sine to the power 8, and then cosine x dx. That's outside these curl brackets. Now we can see that the curl bracket, we could just use sine x equal to u, then du will be equal to cosine x dx. This implies dx equal to du divided by cosine x. Now we will just go ahead and do the changes. So for every sine x, we'll put u. So sine to the power 6 of x is replaced by u to the power 6 of x minus sine to the power 8 of x, u to the power 8 of x, and this is multiplied by cosine x, and then du divided by cosine x. This is replacement for dx, which we talked about, dx equal to this. So we can see that we will go ahead and cancel cosine x with cosine x. So we will be left with just the integration of the inside, everything inside the curl bracket. So the first, its integration will be u to the power 7 divided by 7 minus the second u to the power 9 divided by 9 plus the constant of integration. So this is pretty much the integral that we're looking for. So this is our function, and this is the result of the integral. So this is the answer. And this ends this problem. Let's go on. The next question is question number 8. And it is about integration between 0 to 1/2 of x cosine pi x. And this looks like if we do the integration using the table, it will be quicker and it will be better than going through the other options. So here is a table. Differentiation on this side, integration on this side. For differentiation, we choose the function x. So we have x over here for differentiation, and for integration we choose cosine of pi x. So to start, the first derivative will be equal to 1 and the second derivative will be equal to 0. That's the end. So we only have to do two integrations. Cosine of pi x, its integration is sine of pi x divided by pi, and then the second integral will be negative cosine of pi x divided by pi square. Now we have to map x, we will map it with the sine, and 1 will map it with the cosine, knowing that x multiplied by sine pi x divided by pi will be considered as positive, but then 1 multiplied by negative cosine pi x divided by pi square we will have another negative, so negative and negative will give us positive. So from the table we can deduce that the integration will result in x sine pi x divided by pi plus cosine pi x divided by pi squared. We have to evaluate it between 0 and 1/2. So to evaluate, we just have to plug in, and instead of x to start with the upper limit half, so instead of x we will have half over here, and in the argument of the sign, instead of x we will have half, so it will be pi divided by 2 over here. And for the cosine also, that will be half, so cosine of pi divided by 2 is 0, so we just plugged in 0 over here. Now we have to evaluate using the lower limit. So the lower limit, which is 0, is going to cancel the first term. So the first term is going to be gone because sine of 0 is equal to 0. But over here, cosine will give us 1. But then this one, because it's going to be subtracted, so we will have minus. And then here we have 1 divided by pi square. So it will be minus 1 divided by pi square. And if we collect these, we're going to get the final answer is 1 divided by 2 pi minus 1 divided by pi square. And that's the correct answer. So that's the answer for it. Next, let's go to the next question. That's question number 9. Integration of tan to the power 4x sec to the power 4x dx. Let u equal to tan x. So du will be equal to sec square x dx, and that implies that dx will be equal to du divided by sec square of x. So this is what we were supposed to integrate, and we're going to go ahead and replace tan to the power 4x with u to the power 4x. We will keep sec to the power 4x intact, but then we will replace dx, because dx equal to du divided by sec square of x. So we replace it over here. So this is du divided by sec square of x. But then we know that sec square of x, we can cancel it because we have here sec to the power 4 of x, and that will yield integration of u to the power 4 of x multiplied by sec square of x du. Now we could go ahead and replace sec square of x by its identity. So here is the original one, and here is u to the power 4 x, and over here this is the identity which represents sec square of x. So 1 plus tan square of x. But then we know that we have to also change tan square of x to u square. So this will be equal to u to the power 4 of x, and then 1 plus, instead of tan square of x, u square of x du. Now we have to multiply u to the power 4, take it inside between the parentheses, so we will multiply. It will be u to the power 4 of x plus u to the power 6 of x, which is right here, integration of u to the power 4 of x plus u to the power 6 of x, and this is just a polynomial integration, so it will be equal to u to the power 5 divided by 5 plus u to the power 7 divided by 7 plus c, which is a constant of integration. And that will tell us that our integration of the left hand side will be equal to, we have to replace every u by tan, so that will be tan to the power 5 of x divided by 5 plus tan to the power 7 of x divided by 7 plus c, which is a constant of integration. And that is the end for this question. Let's take a look at the next question. Question is question number 10, and it is about integration from square root of 2 to 2 of the function 1 divided by x squared multiplied by square root of x squared minus 1 dx. We can convert this function into trigonometric one. The way to do it is we can take cosec of y equal to x, which is equivalent to saying sine of y equal to 1 over x. Now we will use this right angular triangle. This is the angle y, and we can see that sine of y equal to the opposite divided by the hypo, which is 1 divided by x. Sine y equal to 1 divided by x, which is consistent with this. Also, cosec of y equal to x. Cosec of y is nothing but the hypo divided by the opposite. So that works fine. Now let's go ahead and do the derivative of both sides. Derivative of sine y will give us cosine of y dy. Derivative of 1 over x will give us negative 1 divided by x squared dx. Now we have to solve for dx. To solve for dx, we have to multiply both sides by x squared. And that will give us dx equal to negative x squared cosine y dy, and we can see that we can replace x squared by its value. We said x equal to cosec of y, so x squared will be equal to cosec square of y. So instead of x squared over here, we change it to cosec square of y. The rest is the same as this one. So now this will be our numerator, and our denominator we can also convert it to trigonometric function y, because x squared, as we said, x squared is equal to cosec square of y. So x squared is replaced by cosec square of y, and the square root of x squared minus 1. Let's take a look at the square root of x squared minus 1 over here. If we take a look at cot of y is equal to square root of x squared minus 1 divided by 1, which is just the square root of x minus 1. So we can just replace square root of x minus 1 by cot of y. So this is our denominator, and this is going to be our numerator. So now we're back to a rational function. Integration, and this is the top and this is the bottom, or this is the numerator, this is the denominator. The good news is that cosec square of y is on the numerator and denominator, so we can cancel them. If we cancel them, we're going to result with this integration from negative cosine y divided by cot of y. But cot, we can take it to the numerator, but we have to change it to tan. So that will give us integration of negative cosine y multiplied by tan y dy. But we know tan y is equal to sine y divided by cosine y. So cosine y will cancel this cosine y, and we'll be left with integration of just sine of y, which is right here, integration of negative sine of y dy. But if we apply the integration of negative sine y will give us cosine y. And we're going to keep the limits for the function of x, because we'll change this one to a function of x. How can we change this trigonometric function to a function of x? We go to the triangle. In the triangle, we have to look for cosine y. Cosine y is the adjacent divided by the hypo. So the adjacent is square root of x squared minus 1, and the hypo is equal to 1. So we can argue that we can replace cosine y by square root of x minus 1 divided by x, because that is the cosine, the adjacent divided by the hypo. So this is the replacement of cosine y. Now we could go ahead and apply these two values, and when we do so, it's going to give us square root of 3 divided by 2 minus 1 divided by square root of 2. And that is the answer for the question. Let's move on to question number 11. Question number 11 is also integration, but this time the function is x squared plus 1 divided by x minus 3 multiplied by x minus 2 squared dx. It looks like we have to do integration by partial fraction, and to do so we will just jump for it. We're going to say that the first is a divided by the x minus 3 factor over here. plus b divided by x minus 2 plus c divided by x minus 2 squared. Now we have to look at the least common denominator of these three, which is this value. This value is the least value that is divisible by all these three denominators. So we'll start from the first one. So we'll take this least common denominator, we divide it by x minus 3, it will give us x minus 2 squared. So we multiply a by x minus 2 all square. And we use the same thing, this denominator, we divide it by x minus 2, we will get x minus 3 multiplied by x minus 2, we multiply that by b. So b multiplied by x minus 3 multiplied by x minus 2. And then finally, this denominator, when we divide it by this denominator, we will get x minus 3. So we'll multiply c by x minus 3. And now we have the function on the right hand side and we have the function over here on the left hand side. We see that the denominator of both is equivalent, and this function is equivalent to the middle one and equivalent to this. That means we have to look at the coefficients. The coefficient of x squared must be the same as the coefficient of x squared over here. The coefficient of x, if there is no x here, but the coefficient of x here will be 0. So if we have a function here that involves x, then it should be equal to 0. So let's go ahead and continue. We know that x squared plus 1, we can write it as 1 multiplied by x squared plus 1. And if we go to the other side, only a and b will be the coefficients of x squared. So if you do the math here, the coefficients of x squared, it will be a and b. So a plus b, and we put x squared outside the bracket. So that means a plus b will be equal to 1. And then we'll go ahead with the coefficients. In green is the coefficient of x squared. In green over here is the coefficient of x. And in green over here is the constant term. The term that is not involved with x, just the constant term. So from the first coefficient, we can conclude that a plus b equal to 1 implies a equal to 1 minus b. So this is one replacement or substitution that we're going to use. Now, the coefficient of x is 0 because we don't have any term of x. So we say the coefficient of x is 0. So this value is equal to 0. The only thing we did is we replaced a by its value because we argued that a plus b equal to 1. That means a is equal to 1 minus b. So for the coefficient of x, we replaced a by 1 minus b and we have this value. So now we could do the math and this will be equal to 0. And this implies that negative 4 minus b plus c equal to 0. This one. And then this will imply also that c equal to b plus 4. And this implies that if we look at the constant term, we have 4 multiplied by a, which is 1 minus b, plus 6b minus 3c equals to 1. This implies that 4 plus 2b minus 3c equal to 1 implies that 2b minus 3c equal to negative 3. So we will continue here, 2b minus 3, and then it's multiplied by b plus 4. So that will be equal to negative 3, implies negative b minus 12 equal to negative 3, which implies b equal to negative 9, and this implies a equal to 10 and c equal to negative 5. Now our integration will replace a by 10, we will replace b by negative 9, we will replace c by negative 5. All what we need to do now is integration. So the answer is 10 ln absolute value of x minus 3 for the first term, and then minus 9, and then ln of absolute value x minus 2 plus 5 divided by x minus 2 plus the constant of integration. Of course, this is the integration of negative 5 divided by x minus 2 square. This integration will yield 5 divided by x minus 2, which we put it over here. So this is the answer, and that's it for this question. This is the answer summarized right here, and we'll go to is question number 12. And question number 12 is about integration of arctan of 4x dx. We could rewrite this as integration of 1 multiplied by arctan of 4x dx. And then we let u equal to arctan of 4x. So du will be equal to 4 divided by 1 plus 16x squared dx. We will let v prime equal to 1, so v will be equal to x. Now we will do integration by parts. So integration of 1 dot arctan of 4x dx equal to u v minus integration of v du, and this is du. So we can observe that over here we have a denominator, but then if we do the derivative with the denominator over here, we get 32x. So we went ahead and put 32x, but that will change the problem unless we divide by 8, because the numerator over here is 4x. 4x will not give us the derivative of the denominator. So the numerator over here, 4x, we change it into 32x by multiplying by 8, and then we took the 8 outside. So 1 divided by 8 will cancel the impact of the 8 we multiplied 4x by. So this will lead us to the integration as being 1 divided by x ln of the absolute value of 1 plus 16 x squared plus the constant of integration. So the answer is x arctan of 4x minus 1 over 8 ln of the absolute value of 1 plus 16x squared plus the constant of integration c. The next question is question number 13. For number 13, we have to do the limit as x goes to infinity of x plus 10 to the power 2 multiplied by sine of pi divided by x, and the numerator will be x to the power 4 plus 2x squared plus 4. So first of all, we have to expand this term. So it's going to be x squared plus 20x plus 100 multiplied by sine pi divided by x, divided by the denominator, which is x to the power 4 plus 2x squared plus 4. So since we have the highest degree x to the power 4, so let's go ahead and divide the numerator and denominator by x to the power 4, and this is what we're going to get. Once we have this, we can just plug in the infinity, and this is what we're going to have. All of them are zeros except sine of pi divided by x, but also this one will be equal to 0. So in general, we're going to have 0 in the numerator, but the denominator we're going to have 1 because when we divide x to the power 4 by x to the power 4, we get 1. So this will give us 0 divided by 1, which is equal to 0, and that is the answer. The answer for this is 0. Let's go to the next. The next question is question number 14. We have to find the value of the sum of a plus b plus c when f is continuous everywhere. And here is our function f. So f of x is a piecewise function. The first branch is 2ax plus 5 when x less than 1. The second branch is bx squared minus 4 when x is greater or equal to 1 less than 2. The third branch is c squared x and x is greater or equal to 2 less than 3. And the last branch is equal to 12 for x greater than or equal to 3. Here we will follow. For x equals to 1, b minus 4 equal to 2a plus 5. Reason we do that is we have to plug in 1 for x. Since we have x less than 1 over here and x greater or equal to 1 over here, that means we have to plug in 1 for x here, and on the first and the second branches we have to plug in x equal to 1, and that's what we're going to get. B minus 4 equal to 2a plus 5. That's the first equation. For the second equation, we have x equal to 2, but x equal to 2 is shared by the second and the third branches. So we'll do the same. We have to plug in x equal to 2 on the second and the third branches. And when we do that, we're going to get 4b minus 4 equals twice c squared. That's our second equation. The third equation, x equal to 3, and we can see x equal to 3 is for the third branch and the fourth branch. So that implies that we have to plug in 3 for x, and that will give us 3x squared equals to 12, which is the third equation. Now, based on these equations, we could go ahead and answer. So equation 3 implies that c equal to plus or minus 2, because if we divide by 3, we'll get c squared equal to 4. And then we want c, so we have to do the square root of 4, which will give us plus or minus 2. So using plus or minus 2 on equation number 2, it doesn't matter which one because it's c squared. So equation number 2, if we plug in here for c, if we plug in 2 or negative 2, it's going to give us the same value. So we'll get 4b minus 4 equal to a. This implies that b equal to 3. Next, using b equal to 3 on equation 1 implies twice a plus 5 equals to 3 minus 4, and that implies that a equal to negative 3. Therefore, a plus b plus c equals to negative 3 plus 3 plus or minus 2, and that will give us the answer as plus or minus 2. Therefore, that's the answer, plus or minus 2. Next is question number 15. For question number 15, given y squared plus 2e to the power negative xy equal to 6. And we have to find the value of y prime at the point 0 for x and 2 for y. So we have to do the derivative. So the derivative of y squared plus 2e to the power negative xy equals 2. Derivative of the first term is 2y prime. Derivative of the second term, we use the product rule, and that will yield this as the derivative. Derivative of the right hand side is equal to 0 because the right hand side is a constant. So derivative of 6 equal to 0. Now we have to recollect the terms. Over here, we'll keep the same first term, and then we take 2e to the x, e to the negative xy, we take it inside the bracket, and it will give us these two terms, and this is equal to 0. Thus, we can solve for y prime, but before we have to take y prime as a common factor, and that's going to give us this as the product or coefficient if you wish for it, and this equal to 2y e to the negative xy. Now we have to solve for y prime, and to do so, this is what we're going to get. Y prime will be equal to twice y e to the negative xy divided by the denominator, which is 2y minus 2x e to the negative xy. This implies if we plugged in 0 for every occurrence of x and plugged in 2 for every occurrence of y, we're going to get this, which is equal to 4 divided by 4, which is equal to 1, and that is the answer for this question. Next question, we're given y equal to arctan of 2 ln of t. Then dy by dx at t equal to 1 equals. So we have to figure it out. So we could just go ahead and do the derivative. So the derivative of arctan x, arctan 2 ln of t, its derivative is 1 divided by 1 plus ln of t squared. And that's equal to 1 divided by 1 plus 0, because t equal to 1, the ln will be equal to 0. And that will give us, the answer is 1. So the correct answer also is 1. Let's go on to the next question. It's question number 17. So question number 17, if y equal to ex raised to the power x, then y prime of 1 divided by e equals to, that's what we're supposed to figure out. So we will go ahead and take the ln of both sides. So ln of y equal to x ln of ex. Taking the derivative of both sides, we get y prime multiplied by 1 divided by y equals to ln of ex plus x multiplied by e divided by ex, and this term will be equal to 1. So we just put it over here, equal to 1. Now we have to multiply both sides by y so that we can solve for y prime. So if we multiply these both sides, that's what we're going to get. We're going to get y prime equal to y ln of ex plus y, and this is equal to, we have to replace y by its value. The value of y is ex raised to the power x. So we'll have here ex raised to the power x of ln of ex plus ex raised to the power x. Thus, if we evaluate y prime at 1 divided by e, this is what we're going to get. We're going to get 1 and then ln 1 and then plus 1. The first, we get 1 from the first one, this one, 1, and then ln 1, and then this is plus 1. And that will be reduced to 1. So the answer is 1. So that's the correct answer. We'll go to the next, number 18. For number 18, we have the function f of x equal to square root of x squared minus 9 divided by x squared minus 5x plus 4 is continuous on the intervals. We have to figure out the intervals. Luckily, the denominator is a polynomial. The domain is the set of all real numbers, but that will be restricted by the numerator, because the numerator has a square root of x squared minus 9, and that will exclude this open interval from negative 3 to 3 will be excluded from the domain. So our domain will be everything except this open interval. So the next thing we have to do is look at the denominator and factor it. When we factor the denominator, it will give us two vertical asymptotes. The first vertical asymptote at x equal to 1 and the second at x is equal to 4. The one at x equal to 1 will not be included because it is in the excluded portion of the domain. It's in between negative 3 and positive 3. So we're not going to include it when we're figuring out the continuity. So the continuity will therefore be from all the way to the left of the value of x. That will give us negative infinity to negative 3, including negative 3, union positive 3, including positive 3, all the way until 4, not including 4, and then union of 4, not including 4, all the way until positive infinity, not including positive infinity. And this is the answer. Let's move on to the next question. Is question number 19. Integration of the function 1 divided by twice the square root of x multiplied by 1 plus x dx. Let u be equal to square root of x, then du will be equal to 1 divided by twice square root of x dx. If we solve for dx, we'll find dx equal to twice the square root of x du. Now we will do some plugging. We know that dx is equal to twice square root of x du. We just move it right here, replacing the 1. So this will be twice square root of x du. We also realize that this x we can also change. We know that u equal to square root of x. So instead of x, we're going to write over here u, because if u is equal to square root of x, then u square will be equal to x. So instead of this x, we replace it by u square. We also realize that these terms can be cancelled because they are equal in the numerator and denominator. So the integration reduces just to integration of 1 divided by 1 plus u squared du, and that will give us arctan of u plus the constant of integration. But then we have to put back the value of the arctan, because it's u here, we have to put it back to square root of x, and that will give us the answer as arctan of square root of x plus constant of integration. That's the answer. The next question, number 20, is we have to do integration of this rational function. But surprisingly, the numerator and the denominator, they have a relationship. The numerator is a derivative of the denominator. So we can do integration by inspection. And that integration by inspection states that whenever we have a rational function where the numerator is the derivative of the denominator, then the integration will be the ln, and that's why we're calling it integration by just observing this relationship by inspection. So we can say that the result of integration is ln of the absolute value of the denominator plus the constant of integration. This is a justification since the numerator is the derivative of the denominator. So the answer is ln of the absolute value of 1 plus x squared e to the power x plus the constants of integration. Let's move on to the next question, which is number 21. We're supposed to locate the horizontal tangents of the function f of x equals to integration between 0 and x of t squared plus t all multiplied by e to the power 2 t divided by t minus 1 dt. This is definitely equal to f of x, uppercase f of x minus uppercase f of 0. Therefore, if we're looking for the derivative of uppercase of x, then that will give us x squared plus x all multiplied by e to the x divided by x minus 1. And this implies that lowercase of f of x equal to the derivative of uppercase of f of x equal to 0 only at x equal to 0 and x equal to negative 1. Why? Because the zeros for this function, they occur only when x equal to 0 and x equal to negative 1. And that's why we identify x equal to 0 and x equal to negative 1 as two critical points. And critical points, they have horizontal tangents. Thus, the answer for this is x equal to 0 and x equal to negative 1 are the places or the location where the function has horizontal tangents. That's it for this question. Next is question number 22, and it's about integration of the function x squared divided by square root of x plus 1 using the limits from negative 1 to 0. This is an integration that we can do using the substitution. So let u equal to x plus 1. This implies that x equal to u minus 1. If we do the derivative of both sides, we get du equal to dx. For x equal to negative 1, which is the limit of integration, lower limit, for x equal to negative 1, u will be equal to 0. Because if we put negative 1 here, u will be equal to 0. And for x equal to 0, which is the upper limit, so x equal to 0 implies u equal to 1. And sure enough, if we plug in here 0, u will be equal to 1. Now that we're ready for executing the integration using the substitution, we're ready for it, so we could go ahead and get going. We know that x squared should be equal to u minus 1 squared because x is equal to u minus 1. And we also know that square root of x plus 1 must be equal to square root of u because u is equal to x plus 1. So our integration is right here. We have to integrate, but before we do any integration, we have to expand the numerator, and that's the expansion of the numerator. Numerator will become u squared minus 2u plus 1. Now we can still do the integration, but this is still a rational function. It's a little bit more challenging, so what we can do is we can convert this equation from rational and make it just polynomial. If we made it a polynomial, how do we make it a polynomial? We can just divide the numerator by square root of u and divide the denominator by square root of u. Denominator will become equal to 1. Numerator dividing by square root of u is just like multiplying by u to the power negative 0.5. And when we multiply each term by u to the power negative 0.5, the first term will lose 0.5. It will become u to the 1.5. The second term will lose 0.5, which will become 2u to the power 0.5. The third term will just be u to the power negative 0.5 because the third term is 1. So 1 multiplied by u raised to the power negative 0.5 will give us u raised to the power negative 0.5. So now it's easier to go ahead and do the integration because it became a polynomial. So the integration of this function still is going to be equal to 2 divided by 5 u to the power 2.5 minus 4 divided by 3 u to the power 1.5 plus 2 u to the power 0.5, and we have to evaluate this one between 1 and 0. If we plug in 1 for every u, it's as if we are just adding the coefficients of all the terms, and that will give us 2 divided by 5 for the first, 4 divided by 3 for the middle, and for the constant it's going to give us, used to be a constant, it's going to give us 2. So we're just adding the coefficients over here. Will be 2 divided by 5 minus 4 divided by 3 plus 2. And then when we plug in 0, 0 is going to be all zeros there, so this will be minus 0. And that's going to give us the right-hand side. The difference between the right-hand side and this is the fact that 2 divided by 5 is same as 6 divided by 15. And 4 divided by 3 is same as 20 divided by 15. And 2 is same as 30 divided by 15. Now we have a common denominator. We can add the values to figure out the answer. And when we do so, the answer will be 16 divided by 15, and that's the correct answer. Let's move on to the next question. The next question, we have to calculate the area of the region enclosed by the curves y equal to 0, square root, y equal to square root of negative x, and y equal to square root of x plus 2. Here is a sketch. Of course, square root of x plus 2, it's just y equal to square root of x, but shifted by 2 to the left. And that's why its origin starts from negative 2 and it moves increasing towards the right. And the function y equal to square root of negative x is obviously originating from 0, and it will cruise going to the left. So these two functions cross each other, but we don't know where. We're interested in the area that looks like a triangle equilateral. It looks like a triangle, but it's not. And we don't know the area where the two are crossing each other. So if we want to do integration to find this area, we need the limits. And now we just have negative 2 and 0. But we cannot use negative 2 and 0 only, because this area is not covered by one graph. It's covered by two sketches. So the left-hand side of this dotted line, the left-hand side has a different function, and the right-hand side has the other function. So the left-hand side here is controlled by x, square root of x plus 2, and the right-hand side here is controlled by square root of negative x. So we have to find this point. But how to find this point? We have to go ahead and equate the values. But before that, let's just make the area of integration very clear. And for doing that, we're going to go ahead and use the value that, or the area that we have to integrate. We can use cross hashing to make it very clear. So here is the cross hashing. The cross hash now makes life easier, but we have to determine where these two functions, y equal to square root of x plus 2 and y equal to square root of negative x, where are these two crossing each other? And that we can figure it out by equating the two. So the square root of negative x equal to square root of x plus 2 implies x equal to negative 1. So the answer of what we're looking for, which is the area, the answer is similar. We can see that the left part here over here starts from negative to an end at -1, as we already decided that these two will have the same value at x equal to -1. So when we do the integration between -2 and -1, the function must be square root of x plus 2, because this area is really controlled by square root of x plus 2 and y equal to 0, and the vertical line x equal to -1. The second half, which is on the right hand side, is controlled by the function y equal to square root of -x and y equal to 0, and the dotted line at x equal to -1. And that's why we have to add integration from -1 to 0 of the square root of -x dx. So this integration will give us the cross-hatched area. And that's it for this question. We can move on to the next question. The last question on the final exam. Integration of 1 divided by square root of 1 minus x squared multiplied by sine inverse of x dx. Letting y equal to sine inverse of x implies sine y equal to x. Taking the derivative of both sides, derivative of sine y is cosine y dy, because y is a function of x. Derivative of x, we'll just put dx. Now we will need a triangle to help us with this. This is our triangle. This is the angle y. So we said y equal to sine inverse of x. That means sine y equal to x. And sure enough, this angle y, its sine is opposite divided by the hypo, which will give us sine y equal to x, which is this in blue right here. Taking the derivative of both sides, derivative of sine y will give us cosine y dy, and derivative of x is just dx. We will use this now. Using the triangle, we conclude cosine of y. Cosine of y is the adjacent divided by the hypo. So cosine y will be equal to 1 square root of 1 minus x squared. Therefore, the integration that we have to perform, we color-coded it. The first part here is the square root of 1 minus x squared, and in green, the same color, that could be replaced by cosine y. So instead of square root of 1 minus x squared, we replace that by cosine y. And since we said also y equal to sine inverse of x, so sine inverse of x will be replaced by y. Now our integration depends on dx. Also, we did the derivative of both sides of this, and the derivative yielded cosine y dy equal to dx. So we're going to replace dx by cosine y dy. Now we can see that cosine y cancels cosine y. And what we'll be left with is this integration of 1 divided by y dy. And that integration should be equal to ln of the absolute value of y plus constant. Thus, the integration that we were supposed to perform of this function will yield ln of the absolute value of sine inverse of x plus a constant. this constant of integration. Therefore, the answer is ln of absolute value of sine inverse of x plus c. And that ends it, and you have a great day. We reached the end of the final exam solution. Thank you for watching.